As more labor is used in conjunction with the fixed capital input, using additional labor results in a diminishing marginal product of labor and an increasing marginal cost of production. Increasing marginal product of labor leads to a decreasing marginal cost, whereas a decreasing marginal product of labor leads to increasing marginal cost. Average product of labor is the quantity produced divided by the amount of labor input. The average product of labor is not the same as the marginal product of labor. In these two equations, where Q is the quantity of the output produced, L is the quantity of labor used, and delta is the symbol for change. The information on the average total cost, average fixed costs, average variable costs, and marginal costs found in this table are illustrated graphically. With dollars on the y-axis and quantity of output on the x-axis, this figure shows four things. 1. The average fixed cost curve is decreasing as quantity of the output is increased. 2. The average variable cost curve is decreasing up to the quantity of output equal to 5, then starts to increase as quantity of output is greater than 5. 3. The average total cost curve is decreasing up to the quantity of output equal to 7, then starts to increase as quantity of output is greater than 8. And 4. The marginal cost curve is decreasing up to the quantity of output equal to 3, then starts to increase as quantity of output is greater than 3. A closer look at this figure reveals three things. 1. The vertical distance between the ATC and the AVC is becoming smaller as quantity is increased. This vertical distance is the average fixed cost. Hence, since the AFC can never be 0 or negative, the ATC will always be higher than the AVC, and both curves will never cross. 2. The marginal cost curve intersects with the AVC at the minimum point of the AVC. 3. The marginal cost curve intersects with the ATC at the minimum point of the ATC. This observation is the result of two important rules. 1. When the marginal cost is less than the average total or variable cost, then the average total or variable cost is declining. When the marginal cost is greater than the average total or variable cost, then the average total or variable cost is rising. To understand this rule of the relationship between the marginal cost and the average cost, we look at class height as an example. Suppose the average height of the class is 5 feet 7 inches. If Yao Ming, the marginal with height equal to 7 feet 5 inches, walks into the room, then the average class height increases. Similarly, if Vern Troyer, aka Mini-Me, from the Austin Powers movies, with the height of 2 feet 8 inches, if he walks into the room instead of Yao Ming, then the average class height will decrease. Suppose instead that Angelina Jolie walks in the class with the height of 5 feet 7 inches, the average class height will not change. In this example, the marginal equals the average. This figure illustrates how the average total cost, the average variable cost, and the marginal cost typically behave. Here's a useful checklist to remember when drawing the ATC, the AVC, and the MC together. 1. Make sure the marginal cost curve cuts through the average total cost curve and the average variable cost curve at their minimum points, and understand the reason for this. 2. Make sure the vertical distance between the average variable cost and the average total cost gets smaller as you increase the amount of production. And 3. Put a small dip on the left-hand side of the marginal cost curve before the upward slope begins. This allows for the possibility of decreasing marginal cost at very low levels of production. We learned that a profit-maximizing competitive firm will set the quantity where the price equals the marginal cost. P equals MC. This profit-maximizing rule is shown in this figure, where a horizontal line depicting the market price is drawn, and the intersection between the marginal cost and the horizontal line shows the profit-maximizing quantity. From this figure, we see that the ATC and the AVC do not play a role in determining the profit-maximizing quantity. However, these two curves play a role in determining the firm's total profit and decision to shut down. Once the profit-maximizing quantity is determined, the firm's total profit earned can be determined by using the ATC curve. From this figure, it shows the firm profit earned using the cost diagram. From this figure, the total revenue generated by the firm is shown by the rectangle formed with the height equal the market price and the width equaling quantity. The total cost incurred by the firm for producing quantity is shown by the rectangle formed with the height equaling to ATC and the width equaling the quantity. This rectangle is depicted by the hash marked area. From this figure, the total profits generated by the firm is shown by the rectangle formed with height equaling the market price minus ATC and the width equaling quantity. This area in this figure is a shaded area without the hash marks. Our graph in the figure shows a firm that is generating positive profits. Positive profits are generated when at the profit maximizing quantity, the market price is higher than the ATC. If at the profit maximizing quantity, again where P equals MC, the market price is below the ATC but above the AVC curve, then the firm is generating losses but will not shut down in the short run. This scenario is depicted in this figure. From this figure, the total profits generated by the firm is shown by the rectangle formed with the height equaling market price minus the ATC and the width equaling quantity. Since the ATC is higher than the price, the profits are negative and the firm is incurring losses. The size of the loss is depicted by the unshaded area with hash marks.